So thank you, Anna, for the presentation. Now we'll enter in the session where EASA experts will come and present the work they have done since the publication of the Special Condition VTOL during the summer. It's first time, I think, that EASA is communicating on the subject. So we are all really looking forward to the presentation. We'll have 8 EASA experts presenting on 8 different subjects, and we have around the room other EASA experts that may answer questions on other subjects if you have. The first one will be Hamdy Sallam from EASA. He's a pilot, and he will present on handling qualities rating method for VTOL.
So good afternoon, everybody. I'll try to keep you awake for the next 20 minutes. We're going to talk about handling qualities, and more specific, modified handling qualities rating method. It's modified because there is already an existing one within AC 25-7D Appendix E, which is meant for CS-25, of course, aircraft. And this one is modified to meet the special condition for VTOL requirements. We're going to talk about probabilities, so a lot of fun things, so try to bear with me here. Okay, so we're going to talk first of all of what is meant by handling qualities and why we think that the handling qualities are important, which requirements from the SC VTOL are addressed, an overall description of the method, some definitions. We're going to talk about handling qualities rating, some definitions which are linked to the AMC to SC VTOL 2510, and also some links to our beloved Cooper-Harper rating scale. Then we're going to go through the minimum handling qualities table from SC VTOL, which is contained in this proposed AMC. And then we're going to go through the definition of the different probabilities that we are assigning to come up with this overarching method. Okay, so we talk about handling qualities every time we have the task of a flight path or trajectory control, and there is a human in the loop. I specifically wrote human and not pilot or crew, because many people are very careful of what words are used. I'm just using human so that we are open for any kind of definition which is going to be used then later for the flight crew licensing. Of course, the handling qualities are the result, okay, of many different things. This include the flying characteristics or control laws. It includes the mechanical characteristics of the inceptors. It includes the visual cues, external visual cues, so the pilot compartment view, for example. But here we are addressing the overall handling qualities because we would like to provide an AMC which works with any kind of aircraft configuration and combination of different inceptors. Because what we really are targeting here, it is the human performance, so we don't want to reach that kind of limit. Okay, so why handling qualities are important? The handling qualities are required to control and maneuver the aircraft. This is to cope with adverse weather conditions, so the control part, and the maneuver part, because if you need also to steer the aircraft, is to avoid, for example, late detected obstacles or traffic. Of course, when this task is performed by a human, this requires some mental or physical compensation. And this compensation reduces the excess workload and increases also the fatigue of the aircrew during prolonged operations. So the better the handling qualities and the less problems we will have in that domain. Humans can be thought of like they have performance as well, so we want to make sure we are not using all the available performance. I hope the Volocopter people will not be angry with me for showing this small animation, but the whole intent was that we would like to aim for something which I've been told is working really well. Okay, so these are the requirements which have some handling qualities, let's say, requirements within. I will not go through all of them, but what I would like to show in this slide that there are many requirements from the special condition VTOL which are dealing with handling qualities. So this AMC, it is going to be covering more than one requirement, and it is describing an overall method that will then need to be, let's say, followed up by more specific tools for each specific requirement. So getting into the details of the method, there are some things we need to point out. First of all, this AMC, which will be published soon for consultation, it is based on the enhanced category. We will then for sure provide you with a basic category AMC, but we will have to adapt the one which is going to be published. And this is because there is a main difference between enhanced and basic about the continuous safe flight and landing compared to the emergency landing capability. It is based, as I said initially, from the AC257D Appendix E original handling qualities required rating method, but this modified version, it includes also nominal flight control condition, and it also has been adapted in terms of atmospheric disturbance and flight envelope probabilities for special condition VTOLs. I would like also to point out that this is an AMC, and any AMC by definition, it is a way to show compliance to the requirements. Of course, any applicant can provide his own method of compliance and propose it to the agency. Okay, so the method is consisting of defining what are the possible flight conditions. And as I stated before, we are defining the flight condition by multiplying different probability values. And these probability values are the ones of being in a particular flight envelope, of being in a particular atmospheric disturbance level, and suffering or not from a failure condition of from the aircraft. And by failure condition, I mean any failure condition which affects directly the handling qualities. Once we have defined the different probabilities, we define a phase of flight. So whether it's a takeoff, a climb, a cruise, or a descent. And for each phase of flight, we define the flight conditions which have a probability greater than 10 to the minus 9. So we are taking away all the flight conditions which have extremely improbable probability, because we don't need to evaluate them. For each flight condition which we have identified, we then have assigned a minimum handling qualities rating based on what is already written in the special condition VTOL. So ideally, when we look at the table, there should be no surprises, because these are all a combination taken from the special condition requirements. However, when we will look at it in closer details, we will see that we have given some alleviations, because we expect that in a severe atmospheric disturbance with lower probability failure conditions, okay, we could have a degradation of the handling qualities. So we are giving, like say, room for this kind of possibility, but always be reminded that for enhanced category, there should always be the possibility for continuous safe flight and landing, and by definition without excessive pilot workload. So it is a degradation of the handling qualities that will still provide to perform the continuous safe flight and landing. Another important thing I would like to point out is that we are not requesting, of course, that all the flight conditions with all the different probabilities are tested, okay, somehow, but only that you actually show compliance. And the way to show compliance to these different flight conditions could be done either by actual flight testing, by simulator, okay, which of course needs to be validated, or by other evidence that can be proposed by the applicants. Okay, so let us get into the details of what are the handling qualities rating. So the ratings are originally taken from the HQRM, but I have adapted the definition part of it. Okay, so we have three different levels: satisfactory, adequate, and controllable. And in the description, you will see that there are some buzzwords which recall to either the 2510 AMC or to the Cooper-Harper rating scale, so that there is no let's say, confusion on the, let's say, link between these other two classifications. So to have satisfactory handling qualities, you need to achieve desired performance, okay? And desired performance is also a link to the ADS 33 kind of mission task elements. Without exceptional piloting skills, and this is written throughout all the different definitions, with minimum pilot compensation. This is to give the direct link also to the Cooper-Harper rating scale, which should not exceed level 3. Adequate performance are handling qualities which achieve adequate performance criteria according again to MTE of ADS 33, or desired performance with moderate pilot compensation. So we are having already a degraded handling qualities because we are either asking the pilot to work too hard or we are not achieving the desired performance. And of course, again, without exceptional piloting skills. And then there is the last level, which is controllable. So it means that you cannot achieve neither desired or adequate, but you can still achieve continuous safe flight and landing, again, without exceptional piloting skills. And we allow for a transient condition or a configuration to retain control. There is also a link to the AMC to 2510, and there is the classification effects that are used during the system safety assessment. So there is a link directly to that, and when we talk about safety effects which are driven by the handling qualities degradation, any safety effect up to major cannot have handling qualities worse than adequate. So already if you're meeting only controllable handling qualities, your safety system assessment should be at least hazardous. Okay, so the flight envelopes. As I said before, we are combining three different probabilities. The first one is the flight envelope. We are not defining yet what are the boundaries of these envelopes because we are expecting applicants not to use the normal CS25 values because, for example, the speeds from CS25 might not make much sense in a VTOL. So whatever is going to be the boundaries of the envelopes, we have defined the three different envelopes: the normal, the operational, and the limited flight envelope. The normal flight envelope is where we expect people to fly. So it's going to be the prescriptive part in the flight manual, and the training is going to let's say, provide guidance on how to stay within the normal flight envelope. The operational flight envelope is going to be the envelope on top of that, which will allow for crew errors or for operational needs or for any kind of external, like atmospheric disturbance. And then there is the limit flight envelope, which is the limit investigated envelope in terms of also structural limits, and that is of course an envelope where we don't expect people to fly a lot, but it's out there because we know that we could have excursions also up to the limit flight envelope. The probabilities are all TBDs because we are going to assign probabilities of staying within a given flight envelope, so in the normal flight envelope, based on the provision which the applicants are going to provide us with. So if they are going to provide us with warnings or visual cues for the boundaries of the envelopes, or whether they're going to provide us with automatic flight envelope protections, we can assign probabilities for remaining within the normal flight envelope and not exceeding the different envelopes. In the AMC, which we are considering of publishing, at the moment we are addressing the same numbers which we have in CS25 world, which, for example, doesn't give more than 10 to the minus 2 credit for flight envelope protection, as long as you have provided the evidence that you have a reliability of at least 10 to the minus 5. But these are all TBDs, okay? We need to gain more experience within the domain, and it has to be something which gets, let's say, agreed with the authority during the design phase. Another interesting topic is the atmospheric disturbance. So the figures and the probabilities which were contained in the original HQRM were taken for measurements done at the greater US airports. Of course, in an urban environment, that figures don't make much sense. So we need to change both the intensity of the gust we're looking at and also the probability associated with that. So within also Eurokai, we're trying to gather some data in order to populate the significant gust values which will assign to different moderate and severe atmospheric disturbance levels. And then we're going to also assign probabilities for their occurrence. On top of that, the special condition VTOL also requires to show controllability also in a steady wind condition, like we do, for example, nowadays with CS27 and CS29. The value of wind in which controllability has to be shown is not defined in the special condition VTOL, and we will probably publish a number to start with in the proposed AMC. The last probability which needs to be accounted for is the failure condition. Again, it is a failure condition which affects the handling qualities. So these are the only failure conditions we are addressing. And as I said before, there is a direct link with the system safety assessment, and there should be a loop of cross-feeding the results of the modified HQRM to the system safety assessment and vice versa, so that if you initially have assessed something like major because it's driven by a degradation of the handling qualities in your SSA, then you need to evaluate it here and make sure that you don't get any surprises, and then you need to change your classification. Okay, so this is the table which is probably going to be proposed. Okay, I know it's a bit confusing, okay, but when you look at it in more details, it is just an attempt to put into a table format what are all the different requirements from the special condition. So as you can see, there is the phase of flight, okay, then there is the three different probabilities. The layout is very similar to the HQRM for those who are familiar with that. We have added the nominal condition row, which is not present in the HQRM because it's only dealing with failure conditions. We have added also some notes. Okay, so note 1 is pretty much saying that there is alleviation, okay, in terms that you can actually have that kind of degraded handling qualities as long as you can either exit the situation by reducing the flight envelope or by showing that it is only a transient atmospheric disturbance condition that can be exited quickly. And then the note number 2 is addressing the red boxes, which are just showing that based on a preliminary calculation by adding the probabilities, those red boxes should be flight conditions which have a probability lower than 10 to the minus 9 and should not be addressed by the evaluation. Last, very interesting part, it is about dealing with probabilities that have an interrelationship. So these probabilities, which I discussed before, are taken separately, but when there is a direct interrelation between the different probabilities, the way to address this in this modified HQRM and also in the original one is to change the flight envelope probability value. So just to give you an example, if we are in the cruise or approach phase and we are addressing a flight condition with moderate or severe atmospheric disturbance level, The operational procedure may require, like for example, in the wind shear condition in fixed wing, to fly to the limit flight envelope by executing a missed approach or a go around. So in that case, you could not use the original determined probability for the limit flight envelope, but the probability should be adjusted to 1. Another case, if we are doing again the cruise or approach phase in moderate or severe atmospheric disturbance level, and we are flying at the boundary of the NFE, then of course we might experience an overspeed due to the gust experienced. In that case, we would fall in the OFE by definition, so the OFE probability should be adapted to 1 and not the one determined before. Another example is based on the failure condition. So let's say, for example, I have a failure condition which removes my flight envelope protection. Then in that case, I will have to adapt the OFE and limit flight envelope. Thank you for your attention.